This is Mrs. Zappia with Lesson 7 from Module 4, Markup and Markdown Problems. Student outcomes for this lesson. Students understand the terms original price, selling price, markup, markdown, markup rate, and markdown rate. Students identify the original price as the whole, use their knowledge of percent and proportional relationships to solve multi-step markup and markdown problems. Students understand equations for markup and markdown problems and use them to solve for the unknown quantities in such scenarios. In Lesson 7, pause the video and copy the essential question. What is the equation to apply multiple discount rates to the price of an item? Let's go over the vocabulary and then pause the video and copy it into your notes. A markup is the amount of increase in a price. The markdown is the amount of decrease in a price. The original price is the starting price, also called the wholesale. Selling price is the original price plus the markup or minus the markdown. The markup and markdown rate is a percent increase or a percent decrease. Most markup problems can be solved by using the equation. Selling price equals 1 plus m times the whole, where m represents the markup rate. And the selling price for the markdown problem is determined 1 minus m times the whole, where m represents the markdown rate. Make sure you see the difference between a markup and a markdown or markup rate. A markup is a dollar amount, where a markup and markdown rate is a percent. That's an important difference. Pause the video and copy the vocabulary into your notes. Resume when you're ready to do example 1. In example 1, a video game markup. Games Galore Superstore buys the latest video game at a wholesale price of $30. The markup rate at Games Galore Superstore is 40%. Use your allowance to purchase the game at the store. How much will you pay, not including tax? So understand that stores will mark up their merchandise so that they make a profit. Write an equation to find the price at the game at the superstore and explain your equation. So remember that we start out with the percent formula, that the quantity is represented by the percent times the whole. Remember that the whole represents the original cost. And a good way to remember that is the letter O in both of those words. So the original cost is $30. The percent is going to be the 100% that you pay for the item plus the 40% markup. And then the quantity is the selling price. So again, our formula is selling price is equal to, now the percent for a markup is 1 plus the markup rate. The markup rate is 40%, and the decimal for 40% is 0.4. 1 represents 100%. And then we multiply that times the whole, which is the original price of $30, also the wholesale rate. So 1 plus 0.4 is 1.4. 1.4 times $30, and that's going to give us our selling price. So our selling price is equal to $42. Whoops, we don't need two dollar signs there. $42 is the selling price. All right, so we've already solved the equation as well. C, what is the total markup of the video game? So what we found in this problem here, in the first part of it, is that we found the dollar amount that is the selling price. And we know that the original price was $30. So it has been marked up by what dollar amount? So we want to find the total markup. Remember that the markup is a dollar amount. So you have the selling price, and you subtract the original amount, and that is going to give you your markup. So the selling price was $42, the original amount was $30, and the markup is $12. You and a friend are discussing markup rate. He says an easier way to find the total markup is by multiplying the wholesale price of 30 by 40%. Do you agree with him? So let's see if that works. We have $30, which is the original amount, times the markup rate of 40%, which is 0.4, and 30 times 0.4 is 12. So that is a good and efficient way to find the markup. In example 2, Black Friday. So Black Friday is the Friday after Thanksgiving, and it is an opportunity to save a lot of money because stores will often give you a discount because of the shopping day, and then they give you an additional discount if you come really early. In this case, a $300 mountain bike is discounted by 30%, and then it is discounted an additional 10% for shoppers who arrive before 5 a.m. So there are two discounts being applied here. This is called a double discount problem. So we're going to find the sale price of the bicycle. And a common mistake is that people assume that this is going to be a total of 40% discount. But it is not, because you get 30% off the original, but then it's discounted 10% off the sale price, which is not the same as 10% off the original price. So avoid that common mistake. Do not use 40% for double discount problems. So our selling price is equal to the percent, and remember that the percent is going to be 1 minus m, where m represents the first discount rate. Then there's a second discount, so we need to multiply that times 1 minus m, where this m represents the second discount rate. You might even want to call that M1 and M2, first discount, second discount rate. And then you multiply that times the whole. And remember that the whole is the original amount before the discount. The whole is the original amount before the discount. So what we're doing in this problem is we are finding the first discount rate, the second discount rate, and multiplying that by the whole. So our first discount rate is 30%, so we're going to use 100% minus 30%, and it's 1 minus 0.3, so 1 minus 0.3, and that's going to give us 0.7. And then the second one is 1 minus 10%, which is 0.10, and that's going to give us 0.9. So altogether, 0.7 times 9 is, or 0.7 times 0.9 is 0.63. So altogether, we are paying 63% of the cost instead of 100%. So double discount can save you a lot of money. Then the whole amount is the original of $300. So 0.7 times 0.9 is 0.63, and that's the percent you are paying of $300. And altogether, that gives us our selling price. So our selling price is equal to $189. In all, by how much has the bicycle been discounted in dollars? So we have $300 originally minus $189, which is the sale price, and that is $111. And that is the amount of discount. Part C. After both discounts were taken, what total percent discount? So in other words, 111 is what percent of 300? Okay, so we're looking for the percent discount. So this is the part This is the whole. And remember that the part is called the quantity. And we are looking for the percent. Let C equal the percent saved, or the percent discount. So we have 111 is equal to C times 300. Divide both sides of the equation by the same number, and C is equal to 0.37. Remember to move your decimal 2 places to convert that decimal to a percent. So we have a 37% discount. If you recall from the previous page, we had a 30% off first, and then we had 10% off that amount. And again, the total discount saved is not 40%. So pay careful attention to that. Instead of purchasing the bike for $300, how much would it be if you bought it before 5 a.m.? Well, we've already figured that out. We've already got our price of $189. All right, so we're going to go ahead to example 3, working backward. Students find the markdown rate, which is the discount rate, given an original price, which is the regular price, and the sale price, the discount price. Students find the total or final price, including sales tax. So this is working backwards because we know the original price and we know the sale price. And we are looking to find out what was that discount rate. Was it 10%, 20%, 30%? Part A. What is the whole quantity in this problem? A car that normally sells for $20,000 is on sale for $16,000, and the sales tax is 7.5%. So this is the original price, and the original price is the whole. So the whole quantity is $20,000. Find the discount rate. So in order to find the discount rate, you need to know how much money you saved. So the amount saved is $20,000. Take away the $16,000 that you paid. So you saved $4,000. And the discount rate is what percent of 20,000 is 4,000. So we can use our equation, quantity equals percent times whole, where the percent is unknown, so we'll let C equal be the percent discount rate. And the whole is the original amount. So we have C times 20,000 because that's the amount before it was discounted. And the quantity is the percent saved, which is 4,000, the amount saved. So we divide by 20,000, divide by 20,000. And a good way to do this problem mentally is to cancel your zeros. That's because you divide by the common factor of 1,000. And that should have one more zero there. So that is 4 over 20, which is 1/5, which is 0.2. So we have C equals 0.2, and that would equal 20%. So the discount rate is 20% off. By law, sales tax has to be applied to the discount price. However, would it be better for the consumer if the 7.5% sales tax was calculated before the 20% discount was applied? Why or why not? In order to answer that question, let's take a look at what the amount would be in both cases. So first we'll figure out if you applied the sales tax first and then the discount. And then the other one will be if you apply the discount and then the tax. So let's make a T-chart. And on the left, we'll do apply the sales tax to the whole. And on the right, we will apply the discount and then the sales tax. and then we'll compare those, and you'll know, is it better for the consumer if you apply the sales tax before the discount or after the discount? So applying the tax to the whole, we have 1 plus 0.7, whoops, not 0.75, 0.075, and that is a markup of tax. And the whole amount was $20,000. So that's 1.075 times $20,000. And that gives us a total of $21,500. So that's applying the sales tax to the whole. Now we'll apply the discount to the new whole amount. So we have 100% minus 20% discount. So that's 1 minus 0.2, which is 0.8. And then we multiply that times the whole amount. And the whole amount now is the new amount because we're applying the tax after the discount. So that's 21,500. So now we apply 0.8 times 21.5, and that gives us $17,200. And that is the final price, including the discount and tax. So on the left side of the problem here, we have calculated the tax on the original amount, and then we found the discount. On the right side, we're going to apply the discount first and then the tax. So on this side, we pay 100% for the item plus 7.5% tax. And remember to use the decimal, so that's 1 plus 0.075. And that gives us 1.075. And then we multiply that times $16,000, which is the sale price. So here you're paying tax on the discounted price. And that gives us a total of $17,200. And that is the final price, including the discount and the tax. So the question was, is it better to have the sales tax applied to the discount price or calculate that after the discount? Why or why not? So what we found is that it doesn't matter whether you apply the tax before or after the discount because you will get the same answer. Because both of the final prices are the same, it doesn't matter which is applied first. This is because multiplication is commutative. The discount rate and the sales tax rate are both being applied to the whole, which is $20,000. Part D. Write an equation applying the commutative property to support your answer. So applying the tax before the discount gives you the equation $20,000 times 1.075, which represents the 100% plus the tax rate, times 0.8, which is the percent that you pay. So that's the 100% minus the 20% discount. And then on this side, you would have $20,000. Let's say what this is before we do the math. On this side, this is applying the discount before the tax. And that would be 20,000 times 0.8, which is the percent you pay for the car, times the 1.075. So here you see the commutative property in action where you have the same numbers, but you switch the order and your answer stays the same. In this lesson, you have learned to find the price after a percent markup is the selling price is equal to the quantity 1 plus m times whole, where m is the markup rate as a decimal. To find the price after a percent discount, the selling price is the quantity 1 minus m, where times whole, where m is the markdown rate, which is also called the discount rate, as a decimal. Find the price including tax. So the total is equal to the quantity 1 plus m times whole, where m is the tax rate as a decimal. And finally, find the price after a double discount. The selling price is equal to 1 minus m sub 1, where m is the first discount, times the quantity m minus eb sub 2, where eb sub 2 is the second discount, rate, times the whole.